Okay, in the lab, you're given the fact that if you have a constant voltage and an initially uncharged capacitor, the voltage on the capacitor is equal to the source voltage times 1 minus e to the negative t over RC. And this RC is what we call the time constant. So you were given a capacitor, and you were given D cells and the generator and A cells and double A cells, and asked to measure the time constant RC and hence the half-life for each battery or each source and the given capacitor. Well, that should be a fairly straightforward exercise, except, and this is not uncommon at this stage, but especially if you're 2/3 of the way through a differential equations course, we would hope that you would understand this function, which you really would about be expected to understand based on having had a pre-calculus course, much less a calculus course. However, we notice that it takes a while to sort these functions out. By the time you finish analyzing your lab data, you should understand this quite well. Now, that was the task. We'll come back to that task and how we might analyze it. But this is your goal. Measure the RC, the time constant. And from that, of course, knowing the capacitance, you can figure out the internal resistance of your source. Now, if you're using the generator, it's not really an internal resistance. It's got, inductance and some resistance, and it's a little more complicated, but maybe kind of the reactance of the generator, and we'll talk about what reactance is in the near future. Okay, another thing that we need to understand in relation to the lab is the nature of a voltmeter and the nature of an ammeter. Because, of course, we're either going to measure current or resistance. You can also do this, you can also use the fact that when you have an uncharged capacitor, the current is going to be equal to the initial current times e to the negative t over RC. And it wouldn't hurt me to write that down. Okay? So the current is this. And of course I'm talking about a series circuit with a source and a capacitor. It's worth mentioning this, although that's what you were doing, that's what you did in every case. We want to be sure that we kind of document that right now. So you have this or you have this. So you can conceivably measure your time constant using the current. So you need to know what happens when you measure current and what happens when you measure resistance. So I'll split this. I'll talk about the meters in the next video.